We're going to talk about some of the simplification of our technology stack, leveraging the Axon Server. Before I get started, one thing I can tell you is, first off, I have at least 4 engineers in the room here that are part of Axonic that are on my team on a day-to-day basis. And so I want to use them in answering any of your questions throughout this conversation. One of the other things that I want to call out is that there were 2 other presentations across, I guess 4 others, across the different rooms prior to me. And one of the things that I've seen that makes me actually feel maybe a little good about myself is that, once again, we all are experiencing very similar problems, scenarios. We're all dealing with the same type of journey in implementing a CQRS ES, whether it's leveraging Axon Server or Axon Framework without Axon Server. So the company I'm with, as I said, is Promontory. Recently, we will be merging both our fulfillment and our technology legs into a single company called Mortgage Path. As you can tell, we do mortgages. So that helps people purchase or refinance their homes, land, condos, you name it. We are a fintech company, and we have been using Axon for the better part of, I think, 4 years now. I'm going to walk you through kind of a little bit of our early days of how we evolved over time. Dead battery. I can talk loud. Here we go. Here we are. So what we have is typical microservice stack. Now, how did we evolve into our microservice stack? And you guys, I'm assuming, can hear me in the back. I project quite well. How we got into this was really organically. We didn't jump in saying we're building the microservice mentality day one. We did kind of follow that, build a monolith, and then as things kind of evolved, things just made sense to not live within, say, our core domain, which is our loan, as you can imagine. Over time, we had to add security and identity into the stack, and it didn't make sense per se to be part of the core domain. Same thing with doc management. Doc management, there's a lot of documentation associated with provisioning a mortgage. We need to know proof of your income. We need to have details about the property itself. There's appraisal, so what's the value of the property? So we can balance the amount of money we're lending against the valuation of the property, so it's not an imbalance. That's all about risk. There's details around the assets, the bank accounts, the liabilities you have. Do you have an auto loan, student loans, etc.? We capture all that in this context. We also had integrations with a number of third parties that, of course, we wanted to isolate from the core context. Now, one of the things you'll notice is, as you, any of you who have participated in a microservice strategy, there's a lot of cross-communication that starts to happen between these components. Inside of a monolith, you're just making simple calls to service beans or certain types of entities inside the system. How we facilitated this in the early days within our stack was using RESTful communication that represents kind of, got created here, solid lines. And then we also had messages going between our different services using a queue-based methodology. Now, of course, when you offer up different means to do similar type tasks, one being asynchronous, one being synchronous, really it came up to independent developers to just make the choice on what they were doing and how they were handling it. And I can't say that one was right or wrong unless we actually demonstrated a problem in production that said, maybe we should have done this the other way. One of the other things of note here is you'll see my color keys here. The blue databases represents actually 2 data stores. These 2 services are services that have a backing by an event store. The interesting point here, and actually I think it was Jonas earlier, or yes, I think it was, who said it, there's interesting things you can attain from storing details around someone logged in, someone failed to log in. We actually do use this mechanism to go and lock out users after X number of failed attempts consecutively. We also can kind of trend certain types of behavior around how users interact with the system and whatnot. We also have, as I said, an event store backing our loan. Audit is quite significant to us. Compliance, it's in our DNA within our the Promontory mindset. So Those also, both of those systems have projections behind them. That's why they're blue. The green here is purely projection, no event store. So what type of projection data store do we have there? Well, we're projecting the data in our loan context in almost a document store mentality, but we are backed on all of these systems by Postgres right now. That was a cognitive choice that we made to simplify from a Mongo on this side, a Postgres there, a Kafka here, or a Rabbit there. We did it all in the early days. It was kind of a drawback of working within a greenfield solution. You almost have too many options. And what we then did was say, we're not solving a business problem, we're just playing with technology. And so what we did was we simplified our stack. Part of this choice came about by some discussions in the early days with Allard here on site. And said, hey, listen, we have a lot of these core capabilities in the Axon framework itself. Why don't you wait, use those other technologies in the future as necessary, but for right now, keep it simple. Kind of an important point. We don't always take advantage of that kind of simple concept. We always, as engineers, like to overcomplicate our world because there is neat technology. But what I can say is this is probably one of the smartest choices we had because we have enough big problems to solve by solving a business domain problem. All right, so we have a document type store storing serialized JSON. In this context, we actually have more of a relational model. We manage all of our branches and organizations, so banking institutions have different branches. You might have an Utrecht branch, you might have an Amsterdam branch, an Hague branch, you name it. Down in analytics, that's our dimensional model. So it's yet another projection that is consuming from the event streams published out of both IAM and the loan context. This is all temporal based. We sit our reporting layer on top of it. And something that's going to be interesting here is you're going to hear a little bit of an evolution that we started to take. I kind of read through what these all were, so I can jump ahead. Or not. Oh, yeah. There we go. Commence strangulation. So the application started to evolve. Oh, here we go. Hold on. Hello. There we go. So the application started to evolve, and based off our lessons learned, and also the introduction of Axon Server from last year, what we started doing was we wanted to simplify the number of joins between the different views that the different microservices we had. We wanted to take out of the equation that concept of location. What I was finding that our developers over time would be spending more time on thinking about the hooks between the different services versus just the concept of the business problem they're trying to solve. And when we started when the concept of queries was introduced as a formal message type, commands, queries, events, it helped us look at a problem, a feature, and talk through it by talking about the command, the request for action, the side effect of the events, and in some cases, the query of the details I need prior to making or issuing a command or making a decision. And so it was a beautiful concept of taking the mindset of Rabbit, the mindset of REST out of the equation and just asking for information. I don't care per se how I get the answer, as long as I get the answer and I can react to that by then issuing further commands to the system to then make state change. Let me actually go here. Oh, I gotta stand closer, I think, or I'm gonna start using the keys. There we go. I think I get the end of the day batteries here. All right. So some of the key points here that are worth noting. In our transition from our first kind of phase of it, no Axon Server and such, what we started introducing was a phased-in approach of Axon Server capabilities. We didn't jump into the Axon event store. I have to go through conversations with my data engineers who are strong advocates of relational databases. They come from a legacy of like Oracle, DB2, et cetera, and they are not necessarily comfortable yet buying into that concept. But what we were able to take advantage was the bus capabilities for commands and for queries. And before we even used the query concept in this mindset, we first had a distributed command bus that we were taking advantage of that was the Spring Cloud version of it. And it was a bit clunky for us. Steven actually did a great job implementing it, backed by console. But it was something else we had to maintain. We had console sitting over here doing the whole discovery mechanism between the clustered instances. Axon Server mitigated that for us. So when we transitioned into introducing Axon Server into the stack, we were able to remove our distributed command bus, a little more simplification within our stack, one less thing I had to be sensitive and aware of. We were also able to softly introduce Axon 4 and 3, while keeping Axon 3 consistent in the stack. And even today, we still have a blend of 3 and 4. There were a couple nuances that we had to factor in. We had to manage some, register some serializers or deserializers, that there were some package name changes. I think it was in the query API, am I right? Yeah. But not a problem though. We have clients that are all running both Axon 3, and then we have other Spring Boot. We're also Spring Boot all of our microservices, supported by an Axon 4. One of the other things we did was, before we actually had Axon Server we knew that Axon Framework had the query API built inside of it. So inside a single process, I could publish a query on the local bus, and it would distribute it to a local handler. And we didn't want to bite off too much in the introduction of Axon Server, right? We didn't want to big bang the concept. The distributed command bus was kind of big enough. What my developers were able to do to plan for the future was, we did what I kind of called, I think I named it yesterday, a Restful Bridge. What the Restful Bridge was, inside of, let's say, our loan context, it needed some sort of insight from IAM. Traditionally, we would have maybe made a RESTful call. Well, we still kind of made a RESTful call, but what we did was, inside of the loan context here, we built a query and we published it. And then we also had a query handler that generated a REST call to a service here that published a query locally and handled it locally. Sounds interesting, right? We were able to run that without Axon Server, but once Axon Server was in place, and in our release that actually just went into production a week ago, we were able to remove that RESTful bridge, remove the query handler from loan, remove the query publisher from IAM, and now we are actually getting that direct communication without, with location transparency. We also, with a number of the queries that we're now leveraging, we were also able to decrease the number of direct queues that were under management by our system. So then we start to go to where our future state lies. Our future state starts to look a little less, I guess, intertwined. Of course, I probably played with the image here a little bit. I can make some of these look better, but that would not prove my point. In this case, really some of the key points I want to talk about are not the purest approach to DDD CQRS, but more of, as I've kind of evolved in my position within the company, I have to have more of a business sense. I have to be sensitive to not just the theory of technology, the theories behind certain principles within DDD CQRS. I also have to think about the practical aspect. And one of the things I started to recognize is in this area right here, and it's not just me, these are my engineers who actually helped prove this point to me. One of the things we saw was, we are spending a ton of time, effort, bug resolution, you name it, on building a read-side model inside of our loan context. It was managing all the state change, but we started using some of our analytics projections, which were doing that time series representation of loan. And I was looking and saying, wow, we're really doubling down on that effort. Why don't we start decreasing the amount of work done inside of the loan context from a read perspective, to the point that we're actually on a path to start removing it completely and making analytics our read model. Now, I guess this kind of, if Allard was in here, this is something that we're talking about, and I think Alberto talked about it too. It's just that ability with a loosely coupled system to have that decision. So now I can make a business choice to save money by separating my write and my read model with very little impact. And how do I do that? Well, if this system is using purely queries, or any of our other systems that are looking to go and access loan data are issuing queries, they don't know where or how that information is provided to them. They are trusting the responder and using that information. And so one of the other things we did in this case that justified my cause here, I think Joris mentioned it earlier, eventual consistency. We always were dealing with eventual consistency. In this case, we didn't really manage for it. We always said, I'm going to return you whatever state is sitting in here. But in our analytics model, as we started using that as the source for our third-party integrations to order credit, to order an appraisal, or to call an automated underwriting system, we needed that data to be correct at a point of time. And so what we did was, inside of our query API, we pass a reference to a pointer in the event store that says, I want you to only return me data if you have processed at least this event. So that means that if you think about our event store, and I say, I care about getting the state of this loan as long as you passed or processed this event. You could have processed events coming in after that, but as long as you hit this one, you are consistent from the point of time I am interested in. You are good to pass that message across, and at some point, we are then going to make our request over to our credit interface, our automated underwriter, whatever. Let me see how we're doing on time. All right, let's see what else there was to talk here. Some of the other things we are doing with Axon Server's latest implementation, they expanded access control. Used to be just read and write. Now there are things that we can do within the context of these different services where I already told you, analytics, it doesn't need to write state. It doesn't need to issue commands. It is purely a consumer of events and able to answer queries. So that's an example right here. I will go and have this application configured to be able to consume events, read events from both these contexts. Second, it will also be able to subscribe as a query handler to answer requests for loan state. So now I'm getting a much more fine-grained set of applications that have boundaries that, once again, help my developers stay within certain parameters so they don't have to mentally think about it and maybe don't put that code in the wrong spot, which happens. One of the other things that we're looking to take advantage of as we start going down the pathway of maybe being a little more comfortable about storing events inside of Axon Server, multi-context. This is interesting to me because this is a place for me to not just have bounded context isolation inside my event store, but also separate by tenant. So now I can go to a banking institution and say, yeah, listen, your data is physically isolated, separate from your competitor's bank. It's something that compliance and due diligence cares about. I'm going to keep going. Not too much was talked about this. There are certain parameters. We have, information security that's always on our back, for rightfully so, right? There's nothing more important than personal information and identity. We do isolate our systems, leveraging best practices with infrastructure. So we do have our public and our private VPNs. Everything behind our gateway is going to be private. You're not allowed to access those directly. We're using TLS, through gRPC, yes. But that's something out of the box that I'm getting because Mark has most kindly just implemented a few properties that we just set values for, and it's there. Also, I already talked about the principle of least privilege, giving each service just the minimal amount of access it needs to do its job, not opening up the world like we and letting anyone do any type of behavior within the stack. I am going to skip this section because the majority of what this was what Joris talked about earlier. It's about setting the messaging standards. The only thing I'll say about it is of utmost importance. The thing with an event-based system, the model, it's not ephemeral. That model sticks with you. And choices you make, you have to deal with them forever. Now, mind you, there are certain types of tools and whatnot, upcasters, et cetera, versioning, you name it, that you can take advantage of. But there are best practices with respect to backward-forward compatibility, keeping it simple, et cetera, that are critical components that you need to factor in. Watch his talk when it's published, and you can get most of the details. He also talked a little bit about blue-green. I say we're blue-green-ish. How do we handle it? Because he mentioned the concept of it, Joris did earlier. We handle it by we have the luxury of having outage windows that don't hit our SLAs. Now what we do is we actually register certain beans as being able to process our token tracking processors, our processing groups, and we warm up our event store on a new database instance. We're running in cloud infrastructure. We're able to provision a new database. We put our app out there in a non-registered set of services that then it starts warming itself up off the event store. Once it's warmed up, we're able to do some analysis on it and whatnot. And then when we're ready to cut over, for the most part, it becomes a DNS repoint. And then we just turn off all our other systems. I know that not everyone has that luxury, but fortunately we do. One of the reasons why that became relevant for us is that the replays during our maintenance window, well, first off, let's be honest, we do those at late hours. And as you get more and more events, that time keeps growing. And we started pushing against our SLA, where all of a sudden we'd have to start reporting outages beyond the accepted window. And so this was our way to go and handle a bunch of, well, first off, the timing issue. The second thing it did, though, was it allowed us to go and encounter and then fix any type of errors before it's a production night when we're doing these releases with a bit of a cloudy mind. With that, I want to really stop and let you guys ask questions, because I have a lot of smart engineers in the room, and then I could stop talking. Thank you. Yes?
Isn't Axon Server would be a single point of failure?
So we run it clustered. So we run it as a cluster. We have 3 nodes in the cluster. I think the recommendation is any odd number of nodes so that you don't have conflicts. I should let you answer this. Did I answer that right? Okay, yeah, good. Yeah, but we run 3, you could run 5, 7, whatever. You just want to make sure that you can have an easy quorum. Other questions?
So you were talking about this, maybe a little bit more about how you set things up for your customer. Do you have one install?
Yeah. It's all SaaS-based. We run it multi-tenant, and we do isolation strategies by really ensuring that a tenant identifier is in the context of each event for that tenant. So that's a mandatory aspect of it. We also do other stuff like correlation IDs that are tied to commands, events, and all messaging, including even the current state, our Rabbit messaging, so that we can get a complete lineage when we go and aggregate logs across our different microservices, so we can kind of get that holistic time series view of what happened across the system from request all the way through side effects. Yeah. Yes? So we start off, yes, of course we do a backup. Kind of smart, right? First step is backup. Second, we provision a brand new set of infrastructure where we do leverage Flyway for the majority of our systems, where it will at least set up the structure of the database with no content. And then we issue the replay by, when we start up our Spring Boot services, we start it with a profile of passive. That enables only the sets of beans that register Axon, register our ability to then do the token processing. And then once we just sit there and tail the results of where the tokens reside versus what the most recent event is. Once they're caught up, we know we're in a good state and we can start doing our analysis on it. We can also, throughout the whole replay process, be monitoring for errors, different exceptions and whatnot. Fortunately, there's been very few cases where we have to reissue a replay during those cycles, but even if we did, we have days before the release is to be publicized. Once that's done during our outage window, we will go and shut down the production active server. We will go register in DNS the passive server. And there will be a small amount, if you think about it, there are a number of events that will have processed in the time where we did the replay versus what was running in the active node. But usually it's such an insignificant number of events that then all of a sudden when we come back up, it's a matter of seconds to relaunch with the profile active on what was the passive, or the green turning it blue, I guess. I don't know how you'd say that. Well, so the event store itself, we actually leave. We never reproduce the event store. So the event store sat on a separate data source from our projections. Does that help? Maybe not. I can see your face. So the event store itself is running on a database. Let's just imagine it's over there, and I have my projection over here. I have my passive is over back by you. We're both looking at that same event store. We don't destroy and reconstitute that system. That stays up. That is long living with just standard backups and such. So we're both consistently pointing at it. The one thing we're not doing is having your service also handle commands or queries. We disable all of those beings in the context of our app. Did that help? Yeah, so some of it, so he was asking about how do I determine the health of the passive nodes. The way that we do that is, first off, during replay, we are monitoring and we are sensitive to any type of errors. People talked about in other talks, the null pointer. Those are always fun, that just pop up randomly, and then if the token stalls out because of it. I do love the talk that you just did prior, talking about that dead letter strategy. That's already on the forefront of my mind, but if anything, I'll probably be pressuring Allard to implement that in the stack, so I don't have to, Jeroen. But that's a fantastic strategy. But so we're monitoring the logs. We have different scripts that we go to execute to just validate quality of the actual data that was projected. But beyond that, we actually just use kind of an old school smoke test. When we hook the app up before it's live, we are running a few of the scenarios through that demonstrate some of the core capabilities and just verify some of the new feature functionality is functioning as designed. Traditionally, on all of the releases we've had, the only types of problems we're finding to date are really the human error tied to configuration, which is one of the biggest focal points for us going forward, is stabilizing that. Yeah. There isn't right now. No plans as of yet, but yeah. Other questions? Yes.
You still have the consistency enough method in place for your projections. How did you implement it?
So they are, and I wish do you have the answer exactly how Kevin and Chance and those guys did it?
Yeah, so there's actually multiple ways.
Here you go, hold on.
Come over here. Steal the light. Right, so I'm Christian. I work with Kaz for the Promontory project. So your question, could you repeat it, please?
How did you implement the eventual enough implementation in your projections?
Yeah, so in the projection we actually there's several ways you can do it. In this case, we simply, with the analytics service, it's simply a matter of a query saying, hey, I have this event, and we just ask, are you up to date already? Are we eventually consistent? And that way it's about as simple as that. You can see like, oh, hey, okay, we're there, I can do what I want, or I wait a bit.
That was by event ID, right?
Exactly, by event ID. So you give an event ID, you say, hey, because the way the analytics service is built is that it always knows exactly which event ID, what's the last one that it has handled.
Yeah.
So that's the way we have solved it.
You're just getting that through the metadata and taking a look at it and process each one.
Yeah, exactly.
Okay, so it's implemented as I'm above this phase.
So yeah,
Yeah.
I called it, I'm at least to that point. I might be further. So I'm going to guarantee that I process that event. I may have processed events past that point, but that's okay because at least in our business case, we said as long as we are as consistent as what we want, at a point in time, we can be more consistent if that's such a thing. Yes, sir.
So we kind of do some of the same, somewhat the same concept, but it's slightly different, not quite as sophisticated. Do you ever have to go back in time, like on the analytics side,
Yeah.
and say, oh, I need it back to this point
Yep.
specifically, not take on new stuff?
That's why. Well, our analytics database is a dimensional model that's also temporal, so we can get what the look and feel of a loan is at any point in time. And that is a case where I can even query and say, it's not just that you process this event, but at this event's point in time, what did the loan look like? We do have that ability. Sorry. Behind you, yeah?
Yeah, I had a question. Are the events totally ordered? So do you always know, even in a distributed system,
Yeah.
which event preceded which other event?
So within the context of a specific domain, we do have consistency in the order. But as you saw, if I could do this, let's even go to this model. I can make it bigger. There. In this case, analytics is consuming from an event stream from both IAM and loan. And there could be things that a user is performing actions on that maybe the IAM events got sent prior to the loan or vice versa. We did have to compensate for that. And we did that by putting kind of dummy placeholders in the context of analytics, where if I see a loan come through and it has a user ID tied to who created the loan, I might not have, if I look up the context, I might not know that user yet in our identity and access, but the fact that that ID was there, we know it's going to come. So we create an empty placeholder, and then once that does come, we hook it up by the identifier. Any other questions? Awesome. Well, I appreciate your time. Thank you.